Good afternoon, class. Good to see you again. Yeah, I have one announcement. So I posted two announcements on the Aju BB, right? So first one is about the third assignment, and the second one is about the final exam schedule and the location. So please be careful. We will take our final exam on the Yeonam Hall, Yeonam관. So not this place. In the midterm exam, we took our midterm exam on the current place. However, for the final exam, you have to go to the Yeonam Hall, Yeonam관. So please memorize this. Yeah. So you can find this place on the Google map, or yeah, anyway, I think you can find this place. So today is Friday, so I have to check your attendance. However, before checking the attendance, let's take a look at this survey Q&A session. So the first question was, excluding viruses or malicious programs, are there legitimate cases where a program is intentionally designed to ignore a kill signal? So yes, excluding the virus, some systems intentionally ignore the kill command's signals. So for example, a database system may catch sig term and delay termination. So the database system had to write down some data on the disk, right? And all the data writing requests cannot be processed instantaneously. So there is some queue that stores the request, and if the DB catch the sig term, terminating the signal, then it cannot immediately kill the process, because there is some requests are remaining in the queue. So before terminating the database system, the DB system have to process all the remaining process, and then it can terminate the program. So the database system usually delay the termination until it safely writes data to disk. And some server programs can ignore other signals, such as sig hop. Its meaning is that controlling, when you got this signal, it means that the controlling terminal is already closed. So sometimes server programs will ignore these kinds of signals. For more details, you can refer this no hop command for the details. And for your information, kill commands not only always send the sig term. So by specifying some signals, you can send different signals instead of the sig termination. Okay, it's all for the first question. And the second question was about the shared memories queue uses. So in the example, we have used a circular queue for the shared memory. However, you can use any data structure what you like. So you don't have to use the circular queue. If you don't like the circular queue, then you can use hash tables or linked lists, etc. So shared memory itself is just a region of a memory shared among the processes. So you can use better data structure for your shared memory. The third question was, in the code example for producer and consumer, it seemed like they have different pointers. So how will we tell the consumer where the producer put the data? So in the shared memory materials, we have seen two shared memory examples. First one was about the circular queue example. So it have used in and out pointers, so they are shared. So there is no issue. However, in the POSIX example, the PTR, the variable PTR, was not shared. So let's see this together. So yeah, it was the circular key example. So in this example, these 2 pointers as well as the buffer is shared through the shared memory region. So the producer and consumer can communicate with this in and out pointers. So there is no issue. However, when it comes to the POSIX producer and POSIX consumer, the variable PTR, their name is same. Consumer has a PTR and producer also has a PTR. However, the name is same. Their names are same. However, actually they are not shared. So this is a local variable, and this is also a local variable. So for example, after producer printing this message, so here is the shared memory region, and this producer will write down the string hello world into the shared memory region, and it tries to move the location of the variable PTR. So this PTR is pointing here, and at that time, the consumer's PTR is initially pointing the first region of the shared memory. So this PTR is pointing here. So there is no shared pointer among between this producer and consumer. However, still there is no issue because the starting point of the shared point is the same, the 0 and the 0. So the producer and the consumer only need to agree on the same offset instead of the inside the shared memory. So agree with the same starting point, then there is no issue. Producer will start writing from the offset 0, and also the consumer will read from offset 0. So and they have the same direction, right? So producer will write down like this, and also consumer will write down the contents like this. So because they start from the same point, there is no issue. Because since the shared memory is 0 initialized, consumer can find out the end of the string, the end of the shared memory. So yeah, so even if there is no shared pointer, they can easily communicate. So yeah, that's our for the Q&A session. Do you have any questions so far? All right. Then let me check your attendance. 실바, 윤민성, 모, 디키나스, 루카스, 조윤솔, 이수민, 레오, 실파, 오렐리, 김민성, 표, 노연우, 노연우, 유나라, 이강민, 완, 한채영, 루슬란, 베네딕트, 안현식, 아므리나, 차승호, 조은재, 이동훈, 네이선, 하미마, 정준희, 이재준, 김동현, 툰, 이민훈, 송민혁, 강희진, 손아현, 김예원, 박승빈, 최지원, 나미, 찬, 김다희, 김민채, 강한결, 전영재, 이주호, 알반, 방채진, 박희현, 강민수, 슈디, 김현중. Okay, did I miss anyone? Good. Okay, let's get started. So today is 5th June, right? So next week, next Tuesday, I will introduce my some research papers, and next Friday, I will shortly take some questions related to the lecture materials. So the contents covered until today will be appeared on the final exam, and as you can see this here, all the orange text test contents will not be appear on the final exam. So if you are not interested in my research topic, you don't have to come to next week or next Tuesday and also next Friday. You don't have to come. I will manually change all your electronic attendance status as attended. So yeah, feel free to come next week. And yeah, these topics will not be appeared on the final exam. Okay, then let's see the last topic, the interprocess communication. So in the previous lecture, we covered some interprocess communication protocols, which are mainly focused on IPC among the same machines, process within same machines. However, today we will gonna focus on interprocess communication among different machines. So we were gonna briefly learn about some networks and sockets and RPC, remote procedure calls. So this is not a network class, but let's see the brief concept of the networks. So a network is a group of connected machines or connected computers that can communicate with each other. So in the Linux kernel, to support the network, we have to implement 3 components. The circuit interface, which is I'm gonna explain soon, and protocol stack, and network device drivers. So for more details about the second and third ones, you have to take the network class. However, we will briefly see the concept of this protocol stacks. So the IP protocol or UDP or TCP protocols are included in this protocol stack. So they implement how the networks will be sent and be received. So IP protocol implements routing between different machines, and UDP and TCP protocols are built on top of the IP protocols, and these UDP and TCP protocols will decide how do we send the data and how do we receive the data. And yeah, so these things are related to this protocol stacks. And also we have to implement this network device drivers for Ethernet or Wi-Fi. But we will not go through about this network device drivers today. So to understand the concept of the protocol stack, we will just briefly understand some parts of the protocol stack. So let's see UDP versus TCP. So for more details, you have to take the network class, but in this class, the system program class, we will just understand the concept of the protocol stack. So I just prepared these 2 examples. So UDP is a user datagram protocol, so it is very unreliable. So when we send the data, it just sent, and it do not check the receiver received the data or not. So it just send the data, and even if some packets or even if some data is lost or dropped, then it doesn't care. So there is no guarantees of the delivery, so some packets may become lost. So and also when we send the data through this UDP, there is no data related to the sequence. So the delivered packets order is not ordered, so not sorted. So the packets may be also received out of order. However, because there is no because it only sends the data, its transmission speed is very fast. And when it comes to the TCP, it is very reliable, and it guarantees the order of the packets. So when you send the data, unlike the UDP, you have to specify the sequence of the data. And after sending the data, you have to receive the acknowledgement packet. So this packet means I received the data well. So in the server side, when you receive the data, you have to send the that saying that the packet is received well. So when it comes to, let's say some packets have become lost, then ECK will not be sent. The sender cannot receive the ECK. So in this situation, the sender will send the same packet again. So this TCP protocol is very reliable and also support the sequence numbers. So the packets can be sorted in order. However, because we have to send the sequence numbers and we have to receive the acknowledgement, their speed is slower than that of the UDP. So these kind of things will be handled through this protocol stack. However, the protocol stack is not today's our focus. So we will we want to see the concept of the socket today. So to support the communication in client and server systems, we have to use the sockets or RPCs, remote procedure calls. And in this client and server computing systems, there is multiple clients who request some things to the server, and there is logically one computer which is called the server, which takes the request from the clients and process the request and gives some return calls to the client's PCs. So there is two ways to support this client and server systems, and let's see the first approach, the socket. So socket is defined as an endpoint for communication. So we have, let's say we have two computers, so host X and web server, and if we want to support communication between these two computers, we have to open the two sockets. So we have to open these two sockets, and these two sockets will act as an endpoint of the communication. So socket is a pair of processes communicating over a network involves a pair of sockets. So, and each socket is associated with a unique combination of IP address and port. So each computer, each server or each client has its own unique IP address. So you can easily think IP address as a home address. So each computer is a home, and the address of the house is an IP address. And port is a sort of a door. So we have multiple doors to go through into the house, right? So to come into the house, we have to use the door, the port. So and each house can have multiple doors, multiple ports, and to communicate, to send and receive data between these two houses, we have to create this socket, and each socket has IP address and the port. So to communicate through this socket, firstly server has to open the port and create the socket. So firstly, server will create the socket and will open the specified port for listening and wait for the client's request. And once the request is received, then server will accept the connection, and we can open the connection. And after the connection is created, we can send and receive the data. And all the connections must be unique. So you cannot have duplicating connections. And as for the ports, we have some port numbers. And the port number below 1024, they are very well known, and they will be used for standard services. For example, web and HTTP server, they will use the port 80. And for the SSH server, we will use the port 22. So it is not mandatory to use this standard. However, because everyone uses these ports for this port 80 for HTTP server and port 22 for SSH server, it is not mandatory to follow this rule, but we usually follow this standard. And the server will open the port and wait for the client's request, and a client will initiate a request for the connection to the to the server through the operating system. And you don't have to care about this local port. Okay, so today we will see the how to program the sockets in C and C++. So in Unix-like operating system, when they treat the network, they will treat network as a file system. So operating system, the network as a part of a file system. So handling socket is similar with handling file system. So when we treat the file system, file input and output, we open the file, read and write the file, and then we close the file. Likewise, when we handle the sockets, we open, we connect the socket, then we send and receive data through the socket, and then we will close the socket. We terminate the socket. So both socket system and file system, they are very similar. So in today, we're gonna see the Berkeley socket standard to implement server and client system. Okay. So here is an example code. So the text is very small and the code is very long, but you don't have to understand the whole code right now. So I briefly explain how the server works. So the server will firstly create the socket, and it will set an IP address and port number to the created socket. So yeah, associate socket with IP address and port number. And then it will wait for the client, and if client try to connect to the server, then server will allow the connection and create a new socket to communicate with. I will gonna explain it again soon. So to use the socket, firstly we have to create a socket. So this socket function will create the socket, and it has 3 arguments: domain, communication types, and protocol. So domain of this domain parameter will decide the domain of a communication, such as IPv4 or IPv6. And the types of communication, for example, TCP and UDP, will be decided by the second and third parameters. So by calling the socket, we can create a socket. And the socket function will return an integer identifier. So in one computer system, and in one server, and in one client, it can have multiple sockets. And to distinguish them, we will use this socket identifier. And its type is an integer. So after creating a socket, the socket function will return an integer identifier. So for example, let's say the ID of the socket is 12. Then this sock will store an integer 12. And yeah, so it will be a unique number, unique integer number. So operating system will handle these socket numbers to distinguish them. And this newly created socket is similar with the telephone without it's like a telephone that unwired. So you cannot directly use the socket to communicate with other process or other computers. So to support the communication, you have to add some address and port numbers. So the bind will do that. So I have told you that a socket is associated with a unique, not unique, IP address and port. So we have to assign IP address and ports to the created socket. So to do that, we have to use this bind function. So to bind that, we have to create the structure and initialize the structure with zeros, and then we will write down the values such as the IP address and port number. And then and we can bind such information with the socket via this bind function. And at here, we can see some unfamiliar functions like htones or htonel, but you don't have to care about them. They will just compare some values to the network byte order, so you don't have to understand the details. So after binding, the server will call this listen function. So this listen function means that this socket sock is waiting for client's request, and this number 5 means this socket can handle 5 clients at the same time. So this listen function will take the socket identifier and the number of the how many connection can be queued in this socket. However, this listen function itself, it's not waiting for the client's request. So as I specified, as I typed here, listen function does not wait until the queue is full, or it does not wait for the client's request. It only makes the socket ready to accept incoming connections. So instead of this listen function, this accept function will wait for the client request. So once the server has received an incoming connect attempt, then this accept function will resolve the request. So when you use the accept function, the server will wait for the client's request. And once the server receives the incoming connect attempt, then this accept function returns a second socket where the data will be transmitted. And the original socket will continue to listen for the additional connection. So this is the most confusing part in today's class. So let's see the code. So originally we have this sock function, sock socket, right? However, after accepting the connection, the new socket will be created. The second socket will be created. And this original socket will remain to listen for the additional connects. So let's see the next slide. So let's see this figure. By using the socket function, we created a socket, the name of SOCK. And with this SOCK, sock, we binded it and we used this listen function, and we also called this accept function. However, after this accept function, the new socket will be created. The sock receive will be created. So when the client and server send and receive the data, this socket receive will be used. So actually, the client socket is connected with server's newly created socket, sock receive. So data will be passed through this 2 sockets, and the original socket will be used for the another client's request. So if you do not create the sock receive socket, when the new request comes, you cannot handle the other request. So to handle that, we will create a new socket, and this new socket will handle this data passing communication, this connection. Any questions so far? Does it make sense? 이해가 됐어요? Do you understand it? Not yet. Okay. Let me explain one more time. So when we create a socket, SOCK is created, and usually server has to handle multiple clients, right? So when you see this listen function, this 5 means that server can wait for the 5 clients. So this backlog value means that how many connections can be queued. So server can handle 5 clients. 5 clients can wait for the server. So this SOCK socket will only handle the connection request from the clients. So when you want to send data between these server and client, you have to use another socket. So to do that, via this accept function, we will create a new socket receive, to pass the data between server and client. So actually, the client socket will be connect to the server's SOCK RECB. So, and at the same time, the socket function, the original socket function, will be remained to wait for the other client's other request. Yeah. So that's all. This time, do you understand? Okay. Any questions so far, or do I have to explain one more time? Yeah. We have to create new socket. So if there is one more client and one more connection, we have to create one more connection. Then we have to create one more socket receive. For example, RECB2. Yeah. If the previous, because we have to create a new one. Any other questions? Okay. Yeah, so that is what server do. So after the creation of the connection, we can, by using read or send or receive function, we can pass some data. We can pass some bytes between the server and clients. So that is these functions are for the client server, and clients have to use some different functions. So so to use the socket in client side, we have to use this connect function. This one is very similar to the server's bind function. So client performs a step similar to binding, but you don't have to call listen or access function for in the client side. So after creating a socket, you have to specify the IP address and port, and then likewise, similar to the bind function, you have to call this connect function to attach some information to the created socket. Yeah, so basically this function is very similar to the bind function. However, this will be used in the client side. And so after connection has been established, you can transmit data. So by using the send and receive function, you can send and receive the bytes data. And this send and receive system calls will take 4 arguments. The socket identifier, because we have to use the socket, and addressing point to data. So we have to specify what data we will send, and the number of the bytes to send, the size of the data, and flag setting. So these 3 things is very intuitive, but I guess that this flag setting is not familiar to you, seems. So the flag arguments will be used to control some special behavior of the send and receive. But this time you don't have to care about that. So the flag 0 means default behavior. So you don't have to understand the flag values meaning. So yeah, by using these 2 functions, you can send and receive data. So here's an example. So we have to specify the socket identifier, and we have to specify what data to send or receive. So because at here, text data, the variable text will be sended, and in this side, the received data will be stored in this variable text, and yeah, the size of the bytes. Yeah, it's very intuitive, right? And after using the socket functions, we have to close the socket. So once communication is finished, both the server and client should close their sockets. So server's socket and client's socket will be closed respectively, independently. So server has to close the server's socket, and client has to close the client's socket. And this close system call initiates a series of operations within the operating system to close a connection. So unlike the file system, the socket cannot directly close. So even after closing the socket, even after this close function call, the socket may still appear in the operating system. So this is a command to show the the opened socket. So it takes time to totally close the socket. Yeah. So these calls are the server and client examples. And when you read the code, you can see that even if we say that this socket can wait for the 5 clients' requests, actually this server only can support the 1 client's request. So this accept function actually connect the clients with the server, right? So when you see the code, this accept function will be only called 1 time. So because it is called only 1 time, only 1 client can be connected to the server. So if you want to connect more clients, you have to call this accept multiple times. So to do that, you have to use some while loops, or you have to use some fork or some thread to support multiple clients. But because I think the kind of things it's beyond our system programming course, I don't want to explain them. So, but you have to understand this code. Yeah. So every remaining parts are very similar to the previous lecture slides. So I will not explain all the details. So until here, we have learned about the Berkeley socket standards, and there is more ways to support the socket. And for example, when you use the Java program, you don't have to call some listen function or a bind function. So this is a date server code which is written in Java. So when you see the code, there is no bind function and also no listen function. So these details will be very among the socket standards. So yeah, that's all. So until here, we have covered the concept of the socket. Do you have any questions so far? Then let's see the last topic, the RPC. The communication using socket is considered as a low-level form of communication. So when you use the socket, you have to send the bytes and receive the bytes. So bytes are an unstructured data. So you cannot directly send the data structure such as hash or linked list. So they are using socket is a low-level form of communication. However, to use a high-level method of communication, you have to use a remote procedure call. And at here, procedure means a function. So RPC is one of the most common forms of remote services. So they are not be only used for the client-server computing. Even in Android system, some internal IPC among the processes are running on via these RPCs. So let's see what is the RPC. So RPC is allowing a client, a caller, to invoke a function on a remote host server. So client can request some things to the server, and so client can invoke some procedure on a server. So by using this RPC, you can call some functions in the server through the client. So client can run some functions in a server. So RPC system will hide the details to allow communication, providing stops. So when you want to call some functions in server, when a client wants to call some functions in server through the socket, you have to pass many bytes, and it is not intuitive and easy. You have to write down many bytes, and you have to define some standards and some grammars to call some functions in the server through the socket. However, RPC will hide the details about them. So by using this client-side stop and server-side stop, you can the RPC can support this allow client to call functions on a host side, the server side. So client-side stop will pack some parameters and function names and transmit to the network to the server. And server-side stop will receive this message and unpack the parameters and will call the actual procedure on the server. So I prepared an example. So in this figure, the client wants to run a function A with parameter x, y, z in the server. So to do that, client will specify the function name and the parameters to the client-side stops. Then client-side stops will pack all the informations and will transmit this information to the server-side stops. And then these server-side stops will unpack the data, and then we'll actually call the function A in the server. Yeah, that is the remote procedure calls. So client stop will create a message buffer, empty message buffer, and will pack the informations into the message buffer, and the message buffer will be sent to the RPC server. And most RPC function calls will be synchronous. It means that the client have to wait for the reply. So it is asynchronous. And when it comes to asynchronous calls, without receiving the reply from the server, you can send more data. So in the synchronous system, you call and you will get reply. However, in a synchronous system, you can call, and then you can get the reply later. So in RP systems, usually you have to wait for the reply. And when you get the reply from the server, then you will unpack the returned code and some arguments and results, and all the results will be handed to the caller. And in the server stuff, the server will receive some message buffers, and the server stuff will unpack the messages. So the function names or parameters will be extracted. And the server stuff will actually call the actual function in the server side, and the result will be packed again and will be sent to the caller, the client. Yeah, that's all for the RPCs. So let me give you an example. So let's say you want to read a say client wants to read in the server. So this 123txt is stored in the server. When you want to do that with the socket programming, you have to define all the things. So you have to, when you use the socket, just passing the name of the file is not enough, right? You have to specify how to read the file and how to call some read functions. So it is not convenient. However, when you use the RPC, then you can directly call this open or read function in the server side. You can usually read this text file. So that's why we use the RPC. Okay, so that's all for the today, and we have covered all the topics that may appear on the final exam. So thank you for your attention through this whole semester. And as I told you, next Tuesday we will have I will briefly introduce my research topics, and there will be no quiz. And I will prepare some survey Q&A session. And next Friday, I will shortly take some questions related to the lecture materials. And Friday, there is no electronic attendance check, but I will give you bonus attendance points on that day. And before ending this class, I will briefly introduce what kinds of papers I will introduce on the next Tuesday. So next Tuesday, I will introduce my two papers and one ongoing research. So my ongoing research is optimizing CPU affinity. So CPU affinity is locating some process to specific CPU cores. So modern computer systems has many cores, right? And multiple programs will be run on the multiple cores. And because the cores share the cache and process will contend to take the CPU cores, the value of cache will be refreshed many times. So, and the contention among the cache will degrade the performance of the CPU cores. So to cover that, when we run multiple programs, I will assign the CPU affinity to. So I will locate some programs to the specific CPU cores to resolve this CPU core and cache contention. And yeah, this is my current research topic, ongoing project. And on Tuesday, I will introduce my previous papers. So one paper is about some mobile system and battery system. So in this work, I implemented this heterogeneous battery system. So I soldered them, 납땜하다, and I implemented some battery scheduling algorithm to support this heterogeneous battery system. So by using this heterogeneous battery system, multiple batteries, I can increase the actual capacity of the battery system, and I also increase the charging speed of the battery system. And I will also introduce this ERDBFS paper. So you have heard about the CPU's frequency, right? CPU's, how can I say? The higher frequency means that the CPU is powerful, but spends some large of electricity. And lower frequency means lower performance and good energy efficiency. So all the operating system has some governors to control this DBFS, decide the frequency of the CPUs. And recently, many studies tried to use reinforcement learning, sort of AI, to decide the frequency of the CPUs. And so this paper is about how to use the reinforcement learning to decide the CPU's frequency. So if you are interested in these topics, you can come next Tuesday. But if you are not interested, you don't have to come. So yeah, that's all for today. So before ending this class, I will take a survey. Okay, that's it. If you're interested, see you next week. Or if not interested, then see you in foreign news. Okay. Enjoy your weekend.